Hey guys, I've got a couple Sencore TC-162 tube testers. I've talked about these a little bit in the past, and I think now's the time to take a little bit closer look at them. Now, this is the first one I got, which seems to pretty well work, although it hums a fair amount when I plug it in, but it seems to work okay. This one I got more recently. It hums less, but also doesn't seem to work right. So first I'm going to try testing some tubes with this guy and then compare them to the other one. I'm hoping between the two I can get one good solid working one, or well, ideally two. I'm going to start out with some 6J6s, new old stock. So these are fairly modern as tube testers go, solid state inside. What's nice about them is they pretty much will test any tube, octal up to through Compactron. Compact, very sensitive shorts test, but it's just an emissions tester, which is fine for doing something like TV work. So for someone like me who works on TVs, this is fantastic. If you want to do 30s radios, no, not so much. So if you're going to work on a wide range of things, you got to have more than one tube tester. This is a good one to have for sure if you're going to work with TVs. It'll even do the little new Visters. It's a little bit weird how it works though. Like you may notice the filament it doesn't show an exact voltage, it just has a range. So like if you have a 12.6 tube volt filament tube, you pick the 11 to 14 range. It's just a little bit of slop in there, but it's close enough. Then you got a load, and then you've got this switch, which is used both rotating through all the positions for the shorts test, and then when you do emissions, you got to put it back in the right position. Easy thing to forget. And then you got grid leakage, and then there's this goofy thing, pin elimination. For most tube types, you won't need to use this at all. But this disconnects certain pins from the tube socket from anything, I believe, and then you've got this, which resets them all back up. Okay, so filament 6 and E5-4. So E for the load, it'll be 5 for the test. This is a dual triode tube, and we use socket 4. Start this off. Oh, and there is a meter 0, but there's no line adjust. Like I said, this is just a quick and simple tester. I don't even have a line adjust. So shorts, we go through all the positions, make sure the short light doesn't light up. And you got to remember to put it back on the right position for the emissions test. So this meter seems to work all right, or this tester seems to work all right, but it is humming quite loudly. If my furnace wasn't running in the back, you could probably hear it better. And very low grid leakage, so that's good. And let me check the other side of the tube, which is the 6th position. And since we already tested it for shorts, you don't really need to go through all the testing again and again. Good emissions and very low grid leakage. Alright, so very simple tester to use. Now, let's check out the other TC-162. Sockets and ground. So similar to the other, a little bit of flashing on the shorts light, but it never stays on. Then we check for emissions and we get nothing. Grid leakage does move up a bit, so it's weird. The meter seems to be working all right, and for the grid leakage test, you get meter deflection, but on emission you get absolutely nothing. Just checking the meter movement seems to be fine. Try wiggling the tube around and check for a loose connection. Nothing. I'll try the other side of the triode again, or the other triode rather. Again, nothing. So I'm going to try another tube type, maybe one that goes in an octal socket, and see if we get anything there. Alright, this time let's go with a 7F7 dual triode Loctal tube. 6 D. Oh, sorry, 6F. 4. Socket. Interesting the way they do the loctile socket here. Doesn't have the usual metal ring inside so much. As you can see a little bit down at the bottom, but not coming all the way to the top. Seems to make it a little bit easier to get in and out. Now that my furnace is turned off, you can hear there's a little bit of a hum in this guy. Shorts. Emissions. Alright, so it seems to be. Oh! Well, what just happened? Suddenly I'm showing emissions. So I was thinking, this might be a dirty function switch. Just this thing getting knocked around. I've yet to look inside this tester. That'll definitely be something I need to do, of course. And let's check the other side. It's 5. That's showing. That's showing dead. Alright. But that's a positive sign. Let's try it on the other TC-162. I think you can really hear the hum in this one. Okay. Don't even bother with the shorts test. Alright. This tube warms up. This one definitely showing emissions on that side, and for the other side. Yeah. So that hum is a little disturbing, but this tester does seem to work properly otherwise. Humming so much this needle's vibrating. But I have gone through this one and serviced it a bit, so take another look later, but first I want to pop open this guy and see what's going on. Let's get on. Okay, there we go. So I think the only semiconductor in here is that guy right there. It's a MOS or a FET. That's what gives it such high input impedance. This looks odd. It's I believe it's a Mylar capacitor. I think that's just from the glue holding it down to the circuit board, though. I don't think that's really a problem. A little bit hard to find these guys, so I'm hoping it's still good. They have really, really low leakage. They're very low noise. Oh, there's a diode. Another diode. Always want to watch for lytic, of course. We always are suspicious for those. I don't think you see anything obvious like fried components. One thing you got to be careful of with these TC-162s is because they have a very sensitive shorts test. You don't want to flood these switches with deoxit because you can form a high, it can lower the resistance between the switch contacts and throw off the shorts test. Or so I've read online. I use solid wire on these, so if I got flexed a few times, one of these wires could break. That'll be one source of trouble. In this case, though, I am rather suspicious of a dirty switch contact, especially on this setup switch. And it does look a bit cruddy, so we'll carefully use some isopropyl alcohol and a Q-tip and clean that up a bit. That switch was definitely dirty. Well, let's see if it made any difference. Just going to flip this back around and fire it up. Okay, here we go again, 7F7. Emissions on the side. Still not on the other though. I checked the wiring and didn't find any obvious problems, and now I'm moving on to these switches. And I'm getting some erratic readings on them. Right now that one's open, closed. I'm getting readings kind of jumping around. I'm finding the same things on some of the other switches. In fact, some I don't seem to be able to get any contact at all. So when I go about cleaning these, I'm not really sure how to do it. They're riveted in place. Perhaps I could pop these off from the top side and squirt cleaner down in there. Or I think what I'll try is if I slide the switches down, it's a bit of an opening down in there. I can try shooting some cleaner down in there, back and forth. Because what these do is these disconnect the pins from the circuit, so they definitely have to be making solid contact, or it's just not going to work right. I went through and cleaned up all the switches, and these do pop off fairly easily, so get that all cleaned out around these once I get this thing working. Alright, so 6J6 again. Go on to lighting up. Just go right to emissions. Alright. Both sides are now working. Fantastic. Let's try that 6AC7 now. Alright, well, excellent. Still want to go through down below and check, make sure the resistors are within tolerance and replace that electrolytic. But this seems to have done the trick, restored basic functionality. I've started work underneath the chassis. First up, I checked the load resistors. These are all in a series string, and you tap them, starting at one end going to the other with increasing resistance. The smaller ones are wire wound and pretty close to spec. The others are all carbon competent, drifted either to the edge of spec or out of spec, so I just went ahead and replaced them all with 1% metal film, very stable quality resistors. And now I want to do the same on this board. I'm going to replace an electrolytic and out of spec resistors, which are tough to test because they're all vertically mounted, so you can't get it one at the other end without taking that board out. Luckily those nuts did come off quite easily. And lift this board up. I want to disconnect a few wires. Some of these are rather short. I'm going to make this a little awkward to work on. I ended a few wires to make it easier to flip the board over, and working on replacing parts now. Took out that electrolytic and found its date code on it, 7042. So this was made at the earliest in late 1970. Might have been made in 71 or 72 if they had some parts laying around. That gives us an approximate date around 1971. And I'm working on the resistors. For example, I just took out this 680 ohm 1 watts resistor. And see, it's measuring pretty high, 855. And that's typical of all these carbon comp resistors. They're all high. It should be within 10%, which would be just a little over 700, and that's well out of tolerance, so that will get replaced. Okay, I finished up with the board and reinstalled it. Also picked off the locking goo on these 2 trimmers because I know after replacing those components I'm going to need to adjust these 2. And that's where the calibration procedure comes into play. To calibrate this, you need to make up a little cell, what they call a calibration cell. It fits into an octal socket. I'll be using something like this. And I'll show you a schematic in a moment so you can get it online. It does involve one oddball component, which is a 100 mega ohm resistor. I suggest you can make it by stringing together a bunch of 22 meg ohm resistors and a 12 meg resistor, which you could certainly do. But I just happened to dig up a 100 mega ohm new old stock resistor that I can use. 2%. I've tested it. It's pretty accurate, so I'll use that. And this, and I need to dig up a diode, and I think 2 other resistors, and I'll be ready to proceed. Okay, here's the calibration cell schematic. You can find this at tubesound.com. Here's what it looks like. That 100 mega ohm resistor, diode, and 2 half-watt resistors. For the diode, I use a 1N4007, which is rated for 1000 volts at 1 amp. It's overkill, but I've got a bunch of them on hand. Also found a complete schematic and service guide at this website. I will try to remember to put a link in the description. And back over at tubesound.com, we've also got instructions. They have a whole article on the Sencore Mighty Mite series, 28, 162, 154, that are all very similar. All sorts of great info. And you can buy some socket savers and remastered manual, setup chart, all that good stuff at this website. Here is what you go through. It's pretty simple once you've got this module made to tweak the grid leakage calibration and the emissions calibration. So that's what I'm going to do right now. Okay, let's give this a try. Got the calibration module in socket number 1 and control set up for 1D4 as indicated, and all the pin eliminators up. Pop this out. There's 2 trimmers on the back. I need to figure out which is which and adjust the correct one. Let's see, okay, they're labeled, good. So grid leakage R21, that's the one right in the middle here. So we're supposed to put this on shorts. 0 the meter. So now switch to grid leakage and adjust R21. That's a good sign. So what we're seeing is this 100 mega ohm resistor is acting on leakage. This thing is that sensitive. Most shorts testers are 1 mega ohm or less. This is 100 mega ohms, 100 times more sensitive. That's why you need that super high voltage resistor. And with it in there, it's showing a lot of grid leakage, which is good. Although a lot of grid leakage, again, is a relative term, but I mean in terms of the sensitivity of this tester, it's showing leakage. Now we want to tweak that control so the meter reads in a line between the question mark and bad. So that would be that line right down there. So you only want to do it on its side if you can avoid it, because gravity affects that meter a little bit. So let's see if I can hold this upright, get my finger on that adjuster, and tweak. That's just about too far. Well, once it gets this right, I'll put a little goo on it. Okay, now for the emissions. Controls are a little bit different. B is still on. C, D goes to 3. And again, socket 1. Set the function switch to shorts, recheck the meter 0, got that. Switch to emissions and adjust the other control until the meter reads 60. So we definitely see that's off. It's on 50 right now. On to the other trimmer, which is in the top right corner. Very responsive, and get that sucker right on 60. Shorts 0. Now it says to check the shorts indicating circuit, switch back to shorts and rotate the D switch through all its positions. Normal short should occur with 5 and 6. Yep. It's very hard for you guys to see with all these lights on. Yes, we do have a shorts on position 5 and 6, and not on the others. So, short, shorts. Alright, I think that is about it. And they suggest that calibration should be good for the lifetime of this tester, but it's a good idea to hang on to this and check this periodically. Use the same settings, pop that device in and verify that you still get the readings as indicated. Alright, now, because this is working so well, and my other one does, I am going to be selling this. I'll tell you that right now. I'm going to clean it up, go through it, check a few more tubes, make sure everything's good, and then I'm going to list it on eBay. I've been listing a few other things too. Some miscellaneous parts I don't need, and I'm going to start listing some TVs as well. I definitely got to thin out the collection. Got more tube testers than I need, and certainly more TVs. Got to get rid of some of the duplicates, free up some space. Here it is all back together. Use a little bit of Novus number 2 to clean up the meter face and the knobs. Got the calibration cell in here for one last check. 60 on emission, and grid leakage right on that line between question mark and bad. Alright, this unit is ready to be used. Hope you enjoyed this look at restoring, calibrating a Sencore Mighty Might 7 TC-162 tube tester.